Commander Daspit had 14 reasons to believe his torpedo worked perfectly fine. 14 times he had pressed the firing trigger. 14 times compressed air had slammed a Mark 14 torpedo out of its tube. 14 times 3,200 pounds of steel and explosive had raced through the water at 46 knots toward the same target. 14 times nothing happened. The target was still there. The Tonan Maru No. 3, one of the largest Japanese fleet oilers in the Pacific, 19,000 tons, sitting stationary in the water less than a mile away, waiting to be sunk. It was July 1943. Daspit had found the single most valuable supply ship he would ever encounter in the entire war. He had fired half his torpedo load at it. Not a single one had detonated. He did not fire his 15th torpedo. He brought it home. 2,000 miles from that moment, back at Pearl Harbor, Daspit carried that last torpedo off his submarine himself and walked it to the office of the man responsible for American torpedo development. He set it on the desk. He said, "This is what your weapon does when it hits something. Now fix it." The Bureau of Ordnance told him the problem was his approach angle. This is the story of how the United States Navy went to war with a weapon it knew was broken, told the men dying with it that the problem was them, and what happened when one quiet commander from Virginia decided to build his entire killing philosophy around never trusting luck again. When Japan attacked Pearl Harbor in December 1941, the American battleship fleet ceased to exist as a fighting force in a single morning. 8 battleships destroyed or damaged in 2 hours. The Pacific was open. Japan controlled every major surface lane from Hawaii to the Indian Ocean. And the United States had exactly one weapon left in any meaningful quantity that could reach inside that empire and hit it where it bled: the submarine. There were 55 American fleet submarines in the Pacific when the war began. Their mission was precise and brutal. Japan had no oil of its own, no rubber, no iron ore worth speaking of. Everything that kept its war machine running came by ship from the conquered territories of Southeast Asia, up through the South China Sea, across to the home islands. Cut those ships and Japan would slowly stop. The engine of an empire runs on supply lines, and supply lines are exactly what submarines are built to destroy. The math was clear. The orders were given. The submarines sailed. And then, on patrol after patrol, in the first months of the war, something went wrong that nobody wanted to say out loud. Commander Tyrrell Jacobs aboard the USS Sargo fired 13 torpedoes during his first war patrol in December 1941. He had good targeting solutions, reasonable approach angles, and no reason to expect failure. 13 torpedoes. Not one detonated. He returned to Pearl Harbor and filed a report stating, in the measured language of a man who understood exactly what he was risking by saying it, that in his professional judgment, the Mark 14 torpedo was defective. The Bureau of Ordnance responded that Commander Jacobs was probably doing something wrong. Jacobs was not alone. Commander Chester Smith on the Swordfish, Commander David White on the Plunger. Patrol after patrol, the same story. Japanese ships in the crosshairs, torpedoes fired at point-blank range, and nothing. Or worse, a premature explosion in open water with no target, which accomplished nothing except telling every escort destroyer within 5 miles exactly where the submarine was. Picture what this meant for the men inside those submarines. You have spent weeks crossing thousands of miles of enemy-controlled ocean. You have lived in a steel cylinder 300 feet long, with 80 men, in temperatures that hit 110 degrees, breathing recycled air that smells of diesel and unwashed bodies. You have evaded aircraft and destroyer patrols and navigated through minefields. You have found your target. You are close enough to read the name on the hull through the periscope. You fire. You hear the torpedo leave the tube. You count the seconds. And then there is silence. The ship keeps moving. Nothing happened. and somewhere above you, the destroyers are already turning toward your position. That was the reality of submarine warfare in 1942. The Mark 14 had 3 separate defects. 3. Each one was known before the war began. The depth mechanism was faulty. The torpedo ran an average of 11 feet deeper than its set depth, passing harmlessly beneath ships instead of striking them. Bureau engineers had documented this in internal testing as early as 1941. They did not tell the fleet. The Bureau had spent years and millions of dollars developing the Mark 14. Admitting it was broken meant admitting failure. The magnetic exploder was worse. It was designed to trigger when the torpedo passed through the magnetic field beneath a steel ship's hull, detonating underneath the keel where the blast would break the ship in two. The problem was that near the equator, where most Pacific war targets were located, the ambient geomagnetic field was different enough from the North Atlantic testing environment that the exploder triggered randomly. Sometimes it detonated 100 yards short of the target. Sometimes it did nothing at all. The Bureau knew about this too. They decided, somewhere in a Washington office far from the South China Sea, that it was an acceptable variable. The contact exploder was the cruelest defect of all, because it was the most counterintuitive. When a torpedo struck a target at an angle, the firing pins worked fine. But on a perfect perpendicular hit, directly into the side of a ship at 90 degrees, exactly the shot every commander practiced and aimed for, the impact was so hard and so direct that the firing pins crushed sideways instead of driving inward. The warhead did not detonate. The harder the shot, the more likely it was to fail. The weapon was most likely to work when conditions were bad, and least likely to work when conditions were perfect. By mid-1942, submarine commanders in the Pacific had started doing what the Bureau refused to do. They ran their own tests. Commander Burl Bass lowered his depth settings by 10 feet, and his hit rate improved immediately. Commander Morton on the Wahoo disabled the magnetic exploders entirely, wrote in his patrol report that they were a danger to the crew, and dared anyone in Washington to court-martial him for it. They did not. Other commanders quietly followed. They were reverse engineering a weapon they were supposed to trust, under wartime pressure, while being hunted by destroyers. Then came Daspit, July 24, 1943. The USS Tenosa, operating in the waters north of Truk. Daspit found the Tonan Maru No. 3, one of the largest oil transport vessels in the Japanese fleet, sitting dead in the water after being damaged by another submarine earlier that day. She was not moving. She was not evading. She was simply there, 19,000 tons of steel and fuel, a target that a submarine crew might encounter once in an entire career. Daspit positioned the Tenosa at perfect range and fired. One torpedo hit. The Tonan Maru shuddered, but did not sink. Daspit fired again, and again. He watched each torpedo strike the stationary hull. He heard the impacts through the hydrophones, a solid metallic clang each time, the sound of a weapon hitting exactly what it was aimed at. No explosion. Just that clang and silence, and the Tonan Maru still sitting there. 14 torpedoes. 14 hits on a stationary target in calm water. 0 detonations. The 15th torpedo Daspit did not fire. He brought it back to Pearl Harbor intact, at considerable risk, 2,000 miles through enemy-controlled waters. He walked it personally to the submarine-based torpedo shop and demanded a full disassembly in front of witnesses. The firing pin assembly was examined under direct observation. What they found was exactly what every submarine commander had been saying for 2 years. Under high-impact conditions, the firing pins collapsed. The harder the hit, the more likely the failure. The Bureau of Ordnance was informed. The Bureau contested the finding. A senior officer at the Bureau wrote in an internal memorandum, after 2 years of catastrophic field reports from combat commanders, that submarine captains were not qualified to evaluate torpedo performance. Rear Admiral Charles Lockwood, commanding submarines in the Pacific, had enough. He authorized his own independent drop tests. His engineers rigged nets and fired torpedoes at them to examine the firing pins after impact. Every test showed the same collapse. Lockwood sent the results to Washington with a letter that, stripped of its formal naval language, said essentially, "Your weapon does not work, and men are dying because of it." The fix took 3 weeks. 3 weeks to correct a problem that had been measurable since before the war began. A hardened firing pin, a simple redesign, and suddenly the torpedoes worked. By the end of 1943, the Mark 14 was finally reliable. The submarine force had been fighting with a defective weapon for 23 months. No full accounting has ever been made of how many ships were not sunk, how many patrols produced nothing, how many careers were ended for poor results that were never the commander's fault. You cannot count things that did not happen. But when the torpedo was fixed, the numbers changed immediately. In 1942, American submarines sank 180 Japanese ships. In 1944, with a working weapon, that number was 492. The difference was not braver men. It was not better submarines. It was a firing pin that crushed inward instead of sideways. One man who had read every one of those failed patrol reports, who had studied what had gone wrong and why, was a quiet 31-year-old commander named Ruben Whitaker. He had just taken command of a brand new submarine called the USS Flasher. He had watched 2 years of the American submarine force fight with its hands tied behind its back, and he had drawn a conclusion that almost none of the men around him had fully reached. In submarine warfare, variables are what kill you. Luck, distance, an imperfect firing solution, a torpedo that might or might not work, any one of these could end a patrol or end a boat. The way you survive, the way you win, is to remove as many variables as possible, every one of them, systematically, until the only thing left is certainty. He pulled his boat into position off the coast of French Indochina, opened his notebook, and began to watch. The crew of the USS Flasher had a problem that nobody wanted to say out loud. Their new captain looked wrong. Ruben Whitaker was 31 years old, lean in the way men get lean when they think too much and eat too little. He wore wire-rimmed glasses that kept fogging in the tropical humidity. He spoke quietly, rarely above a conversational tone, even when he was giving orders that would put 80 men inside a steel cylinder and push it beneath an ocean controlled by the enemy. He had graduated from the Naval Academy in 1934 with a class rank his biographers would later describe, charitably, as undistinguished. Before the war, he had served on surface ships. He had never commanded a submarine in combat. The executive officer, Lieutenant Commander Philip Glennon, had watched a lot of submarine captains. He knew what the good ones looked like. They were loud. They radiated something close to aggression, a constant forward pressure, the sense that they were always about to attack something. Commander Morton of the Wahoo had that quality, the kind of man who walked into a room and immediately made you want to follow him somewhere dangerous. Commander O'Kane of the Tang had it too. Whitaker walked into the Flasher's control room on his first day, stood quietly at the chart table for a long time, and started writing in a small notebook. He kept writing in that notebook for 3 days before he said anything significant to anyone. The Flasher had been commissioned in September 1943 and had completed 2 patrols under her previous commander, 5 ships sunk, 2 damaged, respectable but not exceptional. The crew was competent and experienced and quietly skeptical. They lived packed into a steel hull the size of a modest house, 80 men sharing spaces built for 60, in temperatures that stayed above 90 degrees, breathing recycled air that smelled of diesel and rust, and the particular staleness of too many men in too small a space for too long. They had developed the tight, closed loyalty that submarine crews develop, a loyalty not easily extended to a new captain who wore fog glasses and filled notebooks instead of giving orders. What they needed was simple, and it was the only thing Whitaker could not give them in advance. They needed to believe that when things went wrong at 200 feet, with destroyers overhead and depth charges falling, the man at the con knew exactly what to do. That belief could not be explained or promised. It could only be demonstrated. Whitaker assumed command in December 1943 and immediately did something that confused everybody. He did not attack anything. The Flasher's third war patrol took them into the waters off the coast of French Indochina, hunting Japanese convoys along the supply route from Singapore toward the home islands. The route was well travelled and well defended. Japanese commanders had learned after 2 years of American submarine pressure to run ships in tight formations, with escort destroyers on the perimeter and submarine chasers filling the gaps. Whitaker spent the first 2 weeks of the patrol watching them. He surfaced periodically at night to shadow convoys from a safe distance, recording their movements in his notebook. He tracked the interval between course changes. He documented how each type of escort behaved after a submarine contact, noting that a Fubuki-class destroyer searched differently from a Matsu class. He recorded which convoys ran close to the coast and which ran further out, and what the correlation was between moon phase and convoy scheduling. He noted that Japanese merchant captains made their course alterations at the same intervals regardless of tactical conditions, a habit from peacetime training that war had not erased. His officers watched him fill page after page with pencil marks and began having a conversation that nobody put into words directly, but that everyone was having. Glennon mentioned to the torpedo officer one evening that they had now been on station for 11 days without firing a weapon. The torpedo officer agreed that this was unusual. The chief of the boat, a man named Callahan who had been on submarines since before the war, said nothing. His expression said enough. They thought Whitaker was afraid. They were wrong. But they would not understand why until a January evening in 1944, when the Flasher picked up a convoy of 3 freighters escorted by 2 destroyers moving northeast along the Indochina coast. Other commanders would have approached from 1,500 yards. Standard doctrine, taught at submarine school in New London, suggested 800 to 1,200 yards as the correct attack range, far enough to allow escape, close enough for a reasonable firing solution. Most commanders observed this. Whitaker drove the Flasher to 400 yards. 400 yards is close enough that through the periscope a freighter does not look like a target. It looks like a wall. You can see individual sailors on deck. You can see rust patterns on the hull. And at 400 yards, if one of those escort destroyers turns toward you, there is not enough time to dive to a safe depth before 2,000 tons of warship passes over your position. The approach took 40 minutes. The Flasher moved at 3 knots, slower than a man walks, engines barely turning, every unnecessary piece of equipment shut down to reduce noise. In the torpedo room, Petty Officer Second Class Ray Donahue sat beside Tube 1 with his hand resting on the firing panel, the same position he had held on every practice run for the past 2 years, and tried to understand why the captain was still creeping forward when they already had a good solution at 600 yards. At 600 yards, Glennon said quietly that standard doctrine indicated they had a clean firing solution. Whitaker did not respond. He was timing the nearest destroyer's patrol pattern, which he had been tracking for 30 minutes. He knew that in approximately 4 minutes that destroyer would be on the far side of the convoy, its sonar masked by the propeller noise of the 3 freighters between them. He knew the convoy was about to make a course adjustment he had predicted from 2 weeks of observation. He knew these things because he had spent 2 weeks writing them down in a notebook that his officers thought was a sign of hesitation. At 400 yards, he gave the order. Fire 1, Fire 2, Fire 3, Fire 4. The boat shuddered with each launch. The helmsman called out the time. Whitaker ordered the dive before the first torpedo had covered half the distance to its target. 61 seconds later, the first explosion hammered through the water. The second followed 3 seconds after, then the third, and fourth overlapping. A sequence of concussive blasts the crew felt not as sound, but as physical pressure in the chest and the inner ear, and in the fillings of their teeth. In the torpedo room, Donahue looked at the man next to him. Neither of them said anything. 4 torpedoes, 4 hits. In the control room, Callahan, the chief of the boat who had said nothing and looked sceptical for 11 days, closed his eyes for exactly 2 seconds. Then he opened them and went back to his instruments. The celebration lasted less than 10 seconds. Somewhere above them, the surviving destroyer had found them on sonar. The first depth charge detonated at 150 feet and hit the hull like a hammer strike. Objects fell from shelves. A coffee mug shattered on the deck plates. The second was closer. The third was close enough that the lights flickered and a thin line of water began weeping from a rivet seam in the forward compartment. Whitaker ordered 250 feet and turned directly toward the approaching destroyer. Glennon heard the order and looked up. He opened his mouth and stopped. Turning toward the destroyer that was hunting you was not in any manual. The instinct of every trained submariner was to run, to put distance between the boat and the threat, to use depth and speed and time to break sonar contact. Turning toward the destroyer meant driving into the thing that was trying to kill you. What nobody else in the conning tower had yet reasoned through was this. A destroyer's sonar was calibrated to detect submarines at range. At very close range, the destroyer's own machinery and propeller noise overwhelmed its hydrophones. Close enough, and the submarine vanished from detection entirely. The most dangerous place in the water, directly beneath the enemy, was paradoxically the safest. For 90 seconds, the Flasher moved at 3 knots, at 280 feet, directly beneath the keel of a Japanese destroyer. The crew could hear its propellers through the hull, a rhythmic thrashing 20 feet above their heads. They could hear depth charges being loaded into their racks. In the after-torpedo room, a young engineman named Torres pressed his back against the bulkhead, stared at the overhead, and did not move. The man beside him counted the propeller beats under his breath, not because it helped anything, but because it gave his mind somewhere to be that wasn't inside his own fear. The destroyer moved on. Whitaker ordered silent running. The ventilation stopped. The temperature began climbing past 100 degrees. Men sat at their stations and waited in the heat and the dark while the depth charges kept falling. Further away now, the destroyer working a pattern on water the Flasher had already vacated. After 6 hours, the destroyer gave up. Whitaker brought the boat to periscope depth, looked carefully in every direction, and surfaced. Glennon climbed to the bridge and stood next to his captain in the dark, breathing the night air that felt impossibly clean after 6 hours inside. He looked at the oil slicks and debris fields stretching to the horizon. He thought about what he had just watched, the approach, the patience, the moment at 400 yards, the turn toward the destroyer. He understood now that none of it had been hesitation. Every single decision had been made in advance, in a notebook, while his officers were quietly concluding that their captain lacked the instinct for this kind of war. He said, "Sir, I owe you an apology." Whitaker was already scanning the horizon through his binoculars. He said, "What for?" Glennon said, "I thought you were waiting because you were uncertain." Whitaker lowered the binoculars and looked at his executive officer for a moment in the dark. He said, "I was waiting because I was certain. There is a difference." He went below and opened his notebook and began writing. Below him, Callahan was telling the torpedo room what he thought of the new captain. The words he used were not complicated. The torpedo room agreed. They had their answer. April 13th, 1944. The South China Sea. 6 in the evening. Whitaker had been tracking the convoy since dawn, 12 hours, through the periscope in intervals of seconds, never longer, because a periscope wake in daylight is visible from a destroyer's bridge at half a mile. Up, look, bearings, down. Up, look, speed estimate, down. The plotting paper in the conning tower was covered in pencil marks, course calculations, timing intervals, escort patrol patterns measured in minutes and seconds. Whitaker had filled 4 pages in his notebook. His officers had stopped finding this unusual. They understood now that the notebook was not a sign of a man who could not decide. It was a sign of a man who refused to miss. The convoy was designated High 52 by American Naval Intelligence. 7 Japanese cargo vessels, 4 destroyers, 2 submarine chasers. Somewhere between 40 and 60,000 tons of supplies moving northeast along the Indochina coast toward the home islands. Oil, steel, food, ammunition. Everything Japan needed to keep fighting a war, it was slowly losing. The convoy route ran close to the coast in shallow water, which limited how deep a submarine could dive to escape. The Japanese planners had chosen this route deliberately. Shallow water was supposed to make submarines easier to hunt. Whitaker noted this in his notebook and factored it into the plan. At dusk, he submerged to periscope depth and began the approach. In the torpedo room, Petty Officer Donahue had 6 tubes flooded and ready. He had done this procedure hundreds of times. His hands knew every step without thought. But there was something different tonight, a quality to the silence in the boat, the particular stillness that settled over a crew that had stopped wondering if their captain knew what he was doing and started simply trusting it. 4 months had produced that trust. 4 months of watching, waiting, and then hitting exactly what he aimed at. At 600 yards, Whitaker could see individual details through the periscope, rust streaks on the nearest freighter's hull, a sailor standing on the deck of one of the destroyers, the precise configuration of each vessel's superstructure. He could see enough to know he was close to standard firing range. He kept going, 500 yards. The executive officer's hand moved toward the firing panel and stopped. He had learned to wait. 400 yards. At this range, the nearest destroyer could reach the Flasher's position in under 90 seconds if it turned and accelerated. At this range, a depth charge did not need to be precisely aimed to cause catastrophic damage. At this range, there was no margin for any error of any kind. Whitaker had timed the nearest destroyer's patrol cycle down to 45-second intervals over 12 hours of observation. He knew that in 90 seconds that destroyer would turn away from the convoy's starboard side to begin the outbound leg of its pattern, putting the convoy's own propeller noise between its sonar and the Flasher's position. He knew the lead freighter was about to make a course adjustment. He had seen the same adjustment on similar convoys running this route 3 times in the past 2 weeks. He waited for the destroyer to turn. It turned. Fire 1, fire 2, fire 3, fire 4, fire 5, fire 6. 6 torpedoes left the tubes in 12 seconds. The boat shuddered with each one. Whitaker ordered the dive before the last torpedo was clear of the tube. The bow tilted down. Men grabbed stanchions as the deck angled beneath their feet. 200 feet. 250. The first explosion came at 62 seconds. The second at 65. Then 3 and 4, overlapping so close together they sounded like one extended concussion that the crew felt in their teeth and their chests and the bones of their hands where they gripped their stations. Then 5 and 6. 6 explosions in 11 seconds. For them. The Japanese escorts did not for them. The Japanese escorts did not panic. That was the first thing Whitaker registered from the sonar reports coming up from below. The destroyers were not charging randomly. They were forming a systematic search grid, collapsing the available hiding space into geometric zones. Each destroyer assigned a sector, working methodically from the attack point outward. These were experienced crews who had done this before. 4 destroyers and 2 submarine chasers, 6 vessels in total, executing textbook anti-submarine doctrine in shallow water, where the Flasher's depth options were severely limited. The first depth charge detonated at 100 feet off the port quarter, close enough to shatter a gauge glass in the control room. The second was closer. By the third and fourth, the hull was making sounds that the crew recognized and did not discuss. The metallic groaning of steel under pressure, loads it was designed to handle but preferred not to. Whitaker took the boat to 300 feet, which was approaching the Gato-class design limit, and ordered a turn directly toward the nearest destroyer. It was the same move he had made 4 months earlier on his first patrol, the move that Glennon had not understood until it was over. But this time, the tactical situation was different and more dangerous. This was not 1 destroyer. This was 6. The shallow water meant he could not simply go deep and wait, and the systematic search pattern meant that if the Flasher stayed still, the net would close. The helmsman repeated the course order back with a voice that did not crack, which represented 4 months of change from the first time Whitaker had given this order. For 90 seconds, the Flasher glided at 280 feet directly beneath a Japanese destroyer. The crew heard its propellers through the hull, close enough that it felt less like sound, and more like something happening to the metal around them. Torres, the engineman from the aft torpedo room, was in the control room now at his damage control station, and he kept his eyes on the depth gauge and did not look at the overhead, because looking at the overhead while a destroyer passed 20 feet above you did not help anything. The destroyer moved on and dropped its charges on water the Flasher had already left. Whitaker drove the boat to 400 feet. This was beyond rated operating depth. The hull flexed in ways that produced sounds that had no neutral interpretation. A rivet seam in the forward torpedo room began weeping a steady thread of water. The damage control party packed it with wooden wedges and did not mention it to each other because there was nothing useful to say about it. Then Whitaker ordered silent running. The ventilation stopped. The pump stopped. Every piece of non-essential electrical equipment shut down. The temperature, already above 90 degrees, began climbing. Without ventilation, there was nothing to move the heat away from 80 bodies and the machinery they operated. 100 degrees. 110. The carbon dioxide scrubbers ran at maximum capacity and were barely keeping pace. The Flasher stayed at 400 feet for 19 hours. When Whitaker's patrol report reached Pearl Harbor, a staff officer read that figure, looked at it for a long moment, and asked if it was a typographical error. It was not. 19 hours at a depth beyond rated limits in a boat, with failing air scrubbers and a hull leak in the forward compartment, while Japanese destroyers worked systematic search patterns on the water above. At hour 8, the scrubber chemical compound began to saturate. The material that was supposed to be white had turned brown. Men were moving more slowly than normal, their thinking slightly clouded, which some of them recognized as carbon dioxide saturation, and some of them experienced simply as a heaviness they could not name. The pharmacist's mate moved through the boat with portable oxygen bottles, stopping at each station, administering 30-second inhalations to men who were showing early signs of hypoxia. At hour 17, a sailor in the after battery compartment lost consciousness. His bunkmate noticed because the man stopped responding to a question and slumped sideways off the bench. The pharmacist's mate was there in 90 seconds with a resuscitator, manual compressions, steady and rhythmic, for 3 minutes, until the man began breathing on his own again. Nobody in the compartment spoke. The man was moved to a bunk. Everyone returned to their positions. There was nothing else to do, and everyone understood this. At hour 19, the sonar operator reported that the destroyer signatures were changing bearing in a way that indicated the search was expanding outward, rather than remaining concentrated on the Flasher's position. They were not leaving, but they were looking further away. Whitaker listened to the report, looked at his plot, and waited another 40 minutes. Then he gave the order. Blow negative to the mark. All ahead standard. Surface. The Flasher rose through 400 feet of dark water. When the hatch opened and the night air came in, it hit the crew like something physical. 3 men on the bridge watch collapsed within minutes of reaching topside, not from injury, but from the simple physiological failure of bodies that had been operating past their limits for 19 hours and could now stop. Whitaker climbed to the bridge and removed his glasses and cleaned them with a cloth that was soaked through with sweat. He put them back on and raised his binoculars and looked at what the Flasher had left behind. Debris fields stretched to the horizon. Oil slicks caught the moonlight. Floating cargo and wreckage marked where 7 ships had been 12 hours earlier. 4 of them were confirmed sunk. The other 3 were damaged badly enough that naval intelligence would later count 2 more as probable kills from secondary flooding. Glennon came up beside him and looked at the same horizon and said nothing for a long time. Then he said, "Sir, that was the finest piece of ship handling I have ever witnessed." Whitaker did not respond to the compliment. He looked at the position coordinates in his hand and said, "Transmit our position in clear. The Japanese should be allowed to recover their survivors." Glennon understood the order and what it cost. Transmitting in clear meant broadcasting their position to every listening station within range. It meant every destroyer they had just spent 19 hours evading would know exactly where they were. Whitaker was giving away the only advantage a submarine ever has, which is that nobody knows where it is, so that men who had just spent 12 hours trying to kill him could find their surviving crewmates in the water. There was a long pause. Then Glennon went below and transmitted the position. Whitaker stayed on the bridge. He looked at the debris and the oil and the moonlight on the South China Sea and wrote the last entry in his notebook for that date. The entry, when it was later transcribed into his official patrol report, read 6 torpedoes fired, 4 confirmed kills, 2 probable. Evasion required extended time at depth. No casualties among crew. What the patrol report did not include, what patrol reports never included, was what it had actually cost to spend 19 hours at 400 feet in a boat that was not designed for it. The weight of that particular silence. The man in the after battery compartment who had stopped breathing and then started again. Torres with his eyes on the depth gauge. Donahue in the torpedo room with his hand on the firing panel, which was useless now, waiting because there was nothing else available to do. They had been in enemy waters for 38 days. They had 12 torpedoes left. Whitaker went below, sat down at the chart table, and opened his notebook to a fresh page.